What's up, YouTubers? Jose the CNC here. Hey, today we're going to test whether this door lock electromagnet can resist a force equal or greater than 600 pounds as it claims. Let's get to it. So how are we going to test this 600-pound business? I have in here a crane scale, which is basically an instrument that allows me to measure weight. And the way that it works is that, you recall, this is the plate that comes with the electromagnet. I created this interface that basically bolts into this lower portion of the scale. I'm going to grab it from up here with this eye bolt. And of course, we're going to magnetize the electromagnet so it's going to grab into the plate. So I have this weight system that we're going to add, and that's going to tell us how much force the electromagnet can resist. First thing we need to do is turn the scale on. However, I need to do that in such a way that there is no weight being measured. So right now, it is at 0 weight. I'm going to turn it on. And it's going to be measured in 0. As soon as I pick it up, it's going to be measuring some weight, which is basically how much this thing weighs. So I'm going to put it up here. And now I have to energize the electromagnet. And if you recall, the electromagnet has 400 milliamps. So I'm going to use a battery, and I have this meter here. I'm going to move the potentiometer until we get 400 milliamps. All right, so we have 400 milliamps. Now, when I lower this plate, it's going to be magnetized into the electromagnet. Okay, that's it. Oh, it is there. All right. Now, as you can see, we're measuring 64.5 pounds. You're thinking, well, where is that weight coming from? So I have this gigantor beam in here. It measures 8 feet. However, I have positioned it in such a way that here's the pivot point, and I have 2 feet, this is the short side, and 6 feet on the long side. Now, if you divide the long side by the short side, 6 divided by 2, that gives us 3. So that means that whatever weight I have on this side is being multiplied by 3. So basically, to the eyes of the scale, we're applying a force or a weight equal to 64.7. Now, I'm going to start adding weights. And I have my dumbbells in here. So let's start with 30 pounds. I'm looking at the monitor in there. If I add 30 pounds, it should be 90. I already have 65, so I should go to like 155 pounds. And sure enough, it goes to 150.3, roughly, okay? Let's keep on adding weight. Now, something that I wanted to add, I have a very low travel here. I don't want this thing banging to the floor once this guy becomes detached, and it will become detached at some point in time. Because, of course, we don't know what is the maximum weight that it can sustain. Right now, we know that it can handle 150 pounds. Well, what happens when I add 30 more pounds, which to the eyes of the electromagnet is 90? All right, so we have 240 pounds. And the electromagnet is literally laughing at me like, is that all you have? I guess it's not all I have. Let's put 25 more, which is 75 pounds. 310 pounds, and the electromagnet remains in contact. It's asking for more. 380 pounds. Let's give it some more. Unbelievable. 454 pounds. Now the scale is rated at 600 pounds, so it has room to go. The electromagnet also has room to go. The load is not lifting, so that means that I have more than 450 pounds in there. This is incredible. I'm running out of weights here, so 20 pounds is going to become 60. So it will go past the 500 pounds if it doesn't lift. Whoops, there we go. Okay, So it couldn't do 500 pounds. That's what I wanted to know. How much can it do? 400 milliamps. The question is there a way to make it go to 600 pounds? And by the way, it got really close. Almost 500. That's incredible. All right, so we're at 459 pounds, and before the electromagnet didn't take it. Let's see if we can hold it now. Well, YouTubers, I tried everything that I could think of, and I really cannot see, I don't know where it breaks. I'm gonna say somewhere between 475 and 500. It's definitely not 600. It's not even close. But you know, 500 is already fairly impressive, if you will. I tried the maximum current that I could throw at it. This is a fairly small electromagnet. It's not as big as the one that I had used for the chip picker-upper project. It's also not as strong, I don't think. Not to mention, it was only $30. So, you know, if you're gonna protect your jewelry with a $30 investment, you know, I don't think that if a thief goes in with less than 600 pounds of force, you're going to be able to say, hey, give me back my 30 bucks. I'm going to sue you because it didn't protect my jewelry. Probably if you want to protect something expensive, you will want to get something a little bit more than $30. Nonetheless, 500 pounds, I mean, that's incredible. Considering we have something like, what, 5 or 6 watts going into the electromagnet. 6 watts, that's not a lot of power. I would have not expected a paltry 5 or 6 watts, 6 watts being able to subject itself to a 500-pound force. I mean, basically that means that with these batteries I could probably strap this into my shoes and just get up some beefy piece of steel. It would be able to carry my weight, no problem, right? So incredibly impressed with what the little electromagnet can do. No wonder some people use this as you know, as the magnetic vices on the drill press. Of course, only for like actual steel or, you know, ferromagnetic metals. It's not going to work on aluminum. But if you have ferromagnetic metals, you can use it as a vice, right, or as a magnetic vice. So no question that I'm surprised that it could do 500 pounds. I'm not disheartened because it couldn't go to 600. How much did you think it was going to do? Put it in the comments. And then, you know, I'm positive there are electromagnets that can do way much more than that. I mean, there are electromagnets that can lift up a car, right? I don't know that they can do it with 6 watts. Probably it's going to be hundreds or thousands of watts to do that one, of course. But, you know, cool stuff nonetheless. Hope you liked the video. Hope you enjoy the force that these electromagnets can exert. I want to thank you for tuning to my YouTube channel, and I'm going to see you on the next one.